Hello students, welcome to Install Chemistry class. We believe in democratizing education for all. Today we will be continuing with the chapter Carbon and its Compounds. So let's try to understand what we did and some more properties about ethanoic acid. So ethanoic acid is a colorless liquid with a pungent smell. That means the smell is very different, characteristic. It has pungent smell and has a sour taste. Why it has a sour taste? Because it is an acid. It is same as that of vinegar. Vinegar contains acetic acid, which is what ethanoic acid is. It is water soluble and 5 to 8% ethanoic acid in water is called as vinegar. So vinegar that we use at a home for cooking contains 5 to 8% of ethanoic acid in water. We have also covered esterification in the previous class. So let's try to summarize what it was. Ethanoic acid reacts with ethanol to form the ester, ethyl ethanoate. We did the reaction in the presence of conc H2SO4, which is the required condition. And this was the reaction that we have already done. So let's try to recall it. When ethanoic acid combines with ethanol in presence of conc H2SO4, we get the ester ethyl ethanoate plus H2O. This ethyl ethanoate has a sweet, fruity smell because it is an ester. The reaction between carboxylic acid and alcohol to form an ester is called as esterification. Now let's move to another important reaction, that is saponification. So you can remember esterification and saponification in pairs. Why pairs? Because they are opposite of each other. Yes, in the esterification we prepared ester from ethanol and ethanoic acid, but in saponification we are going to do the reverse. So what was the reaction condition for esterification? Yes, we used conc H2SO4. And what is the opposite of H2SO4? It is an acid. So opposite of acid is a base. So that means for saponification reaction we have to use a base. So let's try to understand. Ethanoic acid is a colorless liquid with a pungent smell and a sour taste. We have already seen that it is water soluble and 5 to 8% of ethanoic acid in water is vinegar. Now let's try to come to the equation of saponification. In saponification, we have taken the ethyl ethanoate ester. To this we are adding base NaOH. Remember I told you the opposite of acid is base. Acid was used in esterification, so we are going to use base in the saponification. When we add ester and base, then this ester will give us carboxylic acid and ethanol. But we don't get carboxylic acid exactly. We get a salt of carboxylic acid. What is this salt? It is the sodium salt of carboxylic acid. Now since sodium is a metal, so sodium gets positive charge and O will get negative charge. So CH3COO negative, Na positive, this is formed. Now it is a soap molecule. Hence, this reaction is called as saponification. So, ethanoic acid reacts with bases to form salt and water because it is an acid. And when an acid and a base combines, just like in neutralization reaction, what is formed? Salt and water. So, this CH3COO negative Na positive is the salt over here and water is formed, just like a normal neutralization reaction. So, we can see that ethanoic acid reacts with carbonates and hydrogen carbonates to form salt water and carbon dioxide gas. Remember we have covered this part. So if we try to summarize, we can see that these two reactions occurs and in both the reactions we get carbon dioxide gas. Carbon dioxide gas can be conformed by passing it through lime water and lime water turns milky. One very important thing over here, in the salt CH3COO Na, we always mention O negative, Na positive. So let's start the last topic, that is soaps and detergents. What are soap? The soap and detergent that we use at home for our cleaning purpose, washing purpose, it all involves chemistry. Let's find out how. So soaps are sodium or potassium salts of long chain fatty acids. Now what is this long chain fatty acids? Long chain means many number of carbon atoms are connected. Fatty acids means that it is a very long carbon compound. Sodium or potassium salts means, in the previous slide we did O negative Na positive. So this was a salt of sodium. Instead of sodium, if I have potassium K, then it will be called as potassium salt of carboxylic acid. So the general formula for the sodium or potassium salts is RCOO negative Na positive. And if I have potassium, I would write it RCOO negative K positive. What is R over here? R over here is the alkyl group. That means the carbon chain. Next thing is, what are detergents? Detergents are the ammonium or sulfonate salts of long chain of fatty acids. So, when we have sodium or potassium salts, we call them soap. When we have ammonium or sulfonate salts, we call them detergents. So, over here we can see the example of detergents. Sodium dodecyl benzene sulfonate, which is also called as SDBS. So, you can see so many carbons are there. That is why we are calling it as a long chain carboxylic acid or long chain fatty acids. So this gives us the sulfonate salts. So instead of carboxylic, we see over here sulfonate as mentioned in the definition, ammonium or sulfonate salts of long chain fatty acids. So when we have carbonate and sodium or potassium, it is soap. When we have sulfonates or ammoniums, they are detergents. Now let's try to understand hard water and soft water, and then we'll come to a point where we'll see how soap and detergents behave when they go in water. So, hard water does not easily form lather with soap, while soft water readily produces lather with soap. What is lather? The bubbles, the foam is formed, that is called as lather. Hard water does not easily form lather, while soft water readily produces lather with soap. Now, let's try to understand how they get the hardness. Now, what we can see that what is the difference between hard water and soft water? So, when we have dissolved salts of calcium and magnesium in water, they produces hardness in water. So calcium and magnesium salts of bicarbonates, chlorides, sulfates, they produce hardness in water. So if they are present, we call it hard water. If they are absent, we call it soft water. Now let's see cleansing action of soap and detergent. How soap and detergent are used to clean stains from cloth. So soaps and detergents have two parts. One is hydrophobic long hydrocarbon chain and other one is hydrophilic short ionic part. So let's see over here. The hydrocarbon part of soap attaches to dirt while the ionic end faces water, forming micelles. What are these micelles? Micelles help dissolve dirt in water, that is cleansing cloth. So when we clean cloth by the cleansing action, then micelles are formed. Let's try to understand whole of it in a step-by-step process. So this is my soap molecule. So if you could see, on this side I have made the carboxylic side C double bond O, O negative, Na positive. So if you see, we have ions over here, negative and positive. So this part is called as ionic head. If I see, I can make a head over here. This is called the head. And this chain, one point, each point that you see edge is a carbon. This long chain is called as a tail. It is made up of carbon atoms. This part has ions, so we call it as head. Now, one thing we are clear with head and tail. Now the second thing. Water is polar in nature. That means in water we have H positive, OH minus. Water is polar in nature. And like dissolves like. So this ionic part, that is the head, will dissolve in water. That means this is hydrophilic part. Hydrophilic means water loving. While this tail is water insoluble, so we call it as hydrophobic. When I say hydrophilic for the head, that means it is water soluble. While this tail, it is hydrophobic, so it will be oil soluble, not water soluble. So this is one molecule of soap. So are you able to understand how we differentiate the parts of the soap molecule in two different ways? And then we come to this first point. So now if I have a cloth which has oil stain on it. So imagine this is my cloth and it has a oil stain. So oil is insoluble in water. Now when I add water and soap to it, what is going to happen? So as this head part is water soluble, so it will stay away from this oil. It will stay close to water. So in the bucket we have water. So that means the head part of the soap molecule will stay away from the oil. So it will arrange itself like this. While the tail part will be close to the oil on the cloth, the stain. Because it is oil soluble. It is hydrophobic. It will stay away from water but close to oil. So the tail part will be close to oil on the cloth. This way, many such soap molecules will arrange themselves around the cloth like this. What do we do once we add cloth, soap, detergent or water in the bucket or in the washing machine? The next part is to turn it. They are rotated at a high speed, or we just agitate them like this, right? Or we just dip them twice and thrice. Now what is happening? We are agitating it. When we do this, this micelle which is just formed, if you see, it will move from the cloth and this oil will be trapped between these tails, while the other side, that is the head side, will be in the bucket water. So when we dip the cloth twice and thrice, we try to rinse it. What is going to happen? This micelle will come out of the cloth like this. The oil droplet will be captured inside, and as we are rinsing again and again in water, this whole molecule from outside is water soluble. So the bubbles you see, they are flowing along with the water as you are rinsing again and again. So these bubbles which have oil inside, which has been removed from the cloth, are then removed, and hence our cloth become clean and the oil is removed along with the bubbles formed, that is the micelle. So this is called as micelle. In this way, micelle helps dissolving dirt in water and cleans the cloth. This is what cleansing action of soap and detergent is. Now let's try to understand one experiment. Effect of soap on oil and water mixture. Well, you could totally understand what we are going to do. We are going to take soap and we are going to dissolve it in oil. Are they soluble? Yes, we need to understand what is soluble and what not. So for this, we will require 10 ml of water and a drop of cooking oil in 2 test tubes. We are going to label them as A and B. Then add few drops of soap solution to test tube B. Not in A, just in B. Then shake both test tubes vigorously for the same period of time and observe the separation of oil and water layers immediately after shaking. So what we see in the test tube A, where there was no soap, oil and water remains separated. But in test tube B, it will be a different outcome. Let's try to understand the reason. Oil and water are immiscible, hence no emulsifier present to mix them. But in test tube B, where we have soap, then we will see reduced separation between oil and water, because soap acts as an emulsifier. That means soap will help to mix 2 of them, oil and water. So if when soap is present, it behaves as an emulsifying agent and it emulsifies water and oil. So the interaction shows us that soap molecules have hydrophilic and lipophilic ends. Now hydrophilic we understand water loving, lipophilic is oil loving. So lipo means lipid, that means it means about oil. So lipophilic means lipid loving, that means oil loving. So the other part of the soap which was hydrophobic can be called as lipophilic because it is water hating but oil loving. It ends that bind with water and oil respectively. Hence, soap helps disperse oil in water, creating a more homogeneous mixture. Now let's try to understand another experiment where we can see effect of soap on distilled water and hard water. For this we require 10 ml of distilled water, which can be obtained from lab or from rainwater in a test tube. To this, take about 10 ml of hard water from a tube well or a hand pump in another test tube. So we have 2 different water samples with us. Now we are going to add soap solution to it. Add a couple of drops of soap solution to both the test tubes. And then we are going to shake both the test tubes vigorously for an equal period of time. Let's observe. So observe the amount of foam formed. In which test tube do you get more foam? So what we can see, observe the formation of any white curdy precipitate. In which test tube do you observe a white curdy precipitate? So where we will see the white curdy precipitate? Let's find out. More foam is formed in distilled water test tube. Why so? Because distilled water is soft water. It does not contain calcium magnesium salts. A white curdy precipitate forms in the hard water test tube because it has calcium magnesium salts presented. So when we add soap to it, it forms a white curdy precipitate. Now some more extra information about Micelle. So we have seen that in the soap molecule structure, Micelle has a hydrophilic end which interacts with water and a hydrophobic end which interacts with oil on the cloth. Hydrophobic tail protrudes out of the water and ionic end remains in water. Then we have seen that in water, hydrophobic tails clusters in the interior and ionic end remains on the surface because ionic is water soluble. Then what exactly are micelles? They are clusters of soap molecules with hydrophobic tails inside and ionic ends outside. They help to trap oily dirt in the center, stays in solution as a colloid due to ion-ion repulsions. For understanding cleansing action, we could see that oily dirt is suspended in micelles and is easily rinsed away. So what it shows us? It shows cloudy due to light scattering by large soap molecules. So we see a cloudy white thing because it scatters light. So this is how we can see the whole process. So we take the cloth which has grease dirt, we dip it in water, we add soap or detergent. Then we see that the soap molecules are interacting with the oil on the cloth according to their hydrophobic tail and hydrophilic end of head. Then the arrangement occurs and on agitating the cloth, the micelle rises up, dissolves in the water of the bucket, and when we rinse it several times, the micelles are removed along with the oily droplet. Now let's try to understand this experiment where we will be seeing the nature of detergents with hard water. So for this we will again take 2 test tubes and each with about 10 ml of hard water. And then we are going to add few drops of soap solution to one test tube and few drops of detergent solution to the other test tube. Of course, we are going to shake them vigorously for the same amount of time and then we will observe the amount of foam formed in each test tube. Do both the test tube have the same amount of foam? And we will also be observing any formation of curdy white PPT. In which test tube is the curdy white PPT formed? What we can see, for the soap test tube, it produces less foam and the reason is reaction with minerals in hard water forms soap scum, the white layer. In case of detergent, it produces more foam. Detergents are formulated to perform well in hard water without forming insoluble compounds. So that is why we use detergents for washing our clothes, not soap, because detergents can perform well in hard water. So in soap, we will find that formed soap scum due to reaction with calcium magnesium in hard water, while in detergents there will be no scum formed as detergents do not react with hard water ions. Now let's try to understand some extra information about alcohols in this chapter. Effect of excessive alcohol on the liver. So excessive alcohol intake leads to fat accumulation in the liver. So some people who consume alcohol but in large quantities, they may face such problems where they have fatty liver situation because of the accumulation of fat in the liver. We see that fat deposits can inflame the liver and potentially leading to alcoholic hepatitis. So what is the risk of alcoholic hepatitis? It may progress to liver failure and death if not addressed. Next thing is liver cirrhosis. Chronic alcohol consumption can cause permanent scarring and damage, which is known as cirrhosis. So let's try to see ethanol as a renewable source. Source of ethanol. Ethanol is derived from biomass, which makes it a renewable fuel. That means we can replenish it, we can renew it. Ethanol burns more cleanly and completely than gasoline. Now let's try to understand some combustion characteristics. Ethanol vaporizes during combustion, leading to a flame production. Substances that vaporize produces flame. Those that don't vaporize burn without a flame. So ethanol will give us flames because it will vaporize. So if we take alcohol and we try to burn it, it will give us flame as it vaporizes easily. With this, we have come to an end to the chapter. Let's try to summarize what we have done in today's class. We have discussed ethanol and ethanoic acid as the important carbon compounds. We have seen their reactions. And we have also discussed about soaps and detergents. We did some experiments related to soaps and detergents with hard water and with oil and water. With this, we have come to an end to today's session. I hope the session was interesting and you have learned so many new concepts. See you in next Install chemistry class. Thank you for watching today's class.